Hello, this is Steve with Renesas Timing University. In this video, I am going to be talking about time domain jitter. In the previous video, I introduced the ideal clock and we talked about the variation on the rising edge. Now, the way we measure this is with an oscilloscope. And the reason we need to know what time domain jitter is especially for digital communication systems. Because I may have a clock and I want to sample some data. So this is my clock, this is my data, and I'm telling the system whenever this edge rises, I want to determine if this data is high or low. So what happens if the variation of this clock causes it to rise in such a way that it violates the data setup and hold time? So it's important for me to determine what is the time domain jitter to ensure that this clock is good enough to sample the data. So the way we measure it is with an oscilloscope. So I'm going to set up my oscilloscope right here. And let's focus on the data. So I look at my oscilloscope and I'm going to set a reference point. So we want to see at which point does this clock cross this reference point. So here it crossed it very late. Here it crossed it very early. But most of the time, this clock is going to cross that reference point right in the middle. Now, if the noise is random, which typically on the Renesas clocks it is, we end up with a Gaussian distribution. And this Gaussian distribution has many properties. We can use it to predict how much these edges would vary and how early they would show up, how late they would show up, using statistics and mathematical analysis. But I want to kind of use this example to kind of show kind of what a good quality PLL is. Again, we are talking about the data clock. The more this moves, then the sloppier the clock is. In other words, if it has a wider distribution versus a very narrow and tight distribution. So if a clock has very, very little RMS or time domain jitter, that means that it's really lining up and has very tight alignment, and that's actually a high quality clock. So customers will ask us to quantify what is the time domain jitter, and we set it up in our lab and we measure it on the oscilloscope. And again, there are different types of time domain jitters. There's period jitter, cycle to cycle jitter, there's PCI Express. And depending on the application, then we can capture the appropriate jitter. So thank you for watching this video, and please take some time to watch more of our Renesas Timing University videos.